Welcome to Wildlife and Water Friendly Gardens 2025. My name is Michelle Scholes. I am the coordinator of this program, and I work here on the campus of Clackamas Community College in Oregon City at the Environmental Learning Center. We're very grateful to all of our sponsors who have contributed to making this such a successful and popular series. Our sponsor is Clackamas Water Environment Services. They enable us to offer these presentations to you all for free. If you would like to make a contribution to the Environmental Learning Center, I'd also encourage you to go to our donation button, because even if a small donation really helps with our programming here. In addition, our partnering organizations, of whom we have Laura from Oak Lodge Water Services here today to help us introduce the topic. We also have support from Greater Oregon City Watershed Council, North Clackamas Watersheds Council, and Alexis represents Tryon Creek Watershed Council. And then we have Clackamas River Basin Council and Clackamas River Water Providers. So thanks very much to those partnering organizations and to our sponsor for helping us with making this series so popular. And I will now turn things over to Alexis, who will introduce our speakers for today. Thanks, Alexis.
Yeah, thanks as always, Michelle. This series has flown by, and I'm really excited that we're going to be wrapping up talking about amphibians. As most of you already know, the brief housekeeping notes for you are to please kindly stay on mute during the presentations. And then also, I'll be taking questions via chat for a Q&A session in the last about 15 minutes we have together today. And we also will have an evaluation link that will be popping in chat too, and that's really helpful for the ELC to be able to plan topics for next year. So we have Lara Christensen today, who brings broad experience from working in nonprofit, government, and grant making. She holds an MS in Environmental Sciences/Studies from the University of Oregon with a focus on sustainable systems, and a BA from Pomona College with a focus on literature, philosophy, and dance. And Lara is also a practicing 500-hour certified yoga instructor. We also have Katie Holzer with us today. Katie is a watershed scientist with the city of Gresham, where she studies urban wildlife and pollution. She has a PhD in ecology and has spent the last 20 years learning about how humans and animals can coexist. And that's a segue right in then for you, Lara, to start us off, and then it'll turn over to Katie.
Great. Thanks, Alexis. Thank you, Michelle. Thanks to Clackamas Community College and the ELC. And I'm so excited to be here representing Oak Lodge Water Services and opening the show for Katie here today. You can change the slide forward. So my part in this is a quick 5 minutes, so I need to start my timer. And I am opening in sharing what it means to be in a watershed and then framing that from an amphibians perspective. So my first slide is, where do our streams go? And this is a picture of a very local space. This is the space in which Oak Lodge Water Services and my local Watersheds Council focuses on North Clackamas Watersheds Council. You can see the creeks and the streams there. And over on the left-hand side of the slide is the Willamette River. So besides these waterways, obviously there are many, many pockets of habitats, including ones that you might find in your own backyard. And ultimately, the water quality that we receive onto our yards ends up in these local creeks and then to the Willamette River. Go ahead and forward the slide. So one piece that I like to remind people is, for a watershed, we have the high point all the way down to the low point. And the watershed is that little sub-watershed basin. So if you think about that as applied to both pervious and impervious surfaces, this slide shows how water falls onto a surface and then either penetrates in and filters through, or stays on top and runs across and ends up in puddles or lakes, ponds, larger spaces. So the more places that we have where the water can penetrate and infiltrate, it helps the water to filter and become clean. The other thing that happens, if you want to do the next slide, is that we have different ideas of how development is supposed to happen for our watersheds. So if you think about what's outside of your own door, you might be noticing that in this slide, we have two different examples of traditional development or low impact development. Low impact means there's more space for potential habitat to be happening outside your door. And this might mean that your parking lot has a bioswale. It might mean that your backyard has a rain garden. It might mean that the roadway has a swale on the side of it. And one of the little things that I like to think about is each one of those are mini watersheds. Those are mini spaces for habitat. And when Katie gets into her presentation today, we're going to hear about some of the needs of amphibians. And when I think about the world outside my front door, I want to find lots of pocket spaces where habitat actually could be created. Next slide, please. Okay, if you want to space through, this looks like it's one where it kind of creeps through and presents more information. Thank you, yeah. So just very quickly on this slide, you can think about how if we have more impervious surfaces, there's more place for pollution to run off and hit our waterway. So the more spaces we have that are able to infiltrate, like we talked about with that low impact development, the better chances are of our amphibians, and in this picture, our fish, are going to have for surviving with less polluted water. Next slide. Here's another example of how you could think about how your habitat space could change slightly. Instead of a creek or a pond being sharply sided down to the bottom of the watershed, there would be these different spaces for the water to run through, end up at the bottom where there's those macroinvertebrates or amphibians, but also have these shelves and parks and roadways, pathways, places for habitat to exist, including humans. Next slide. So these things are called stormwater facilities. And this picture has just a couple of pictures to remind us that every storm basin on the side of a road takes water from your edge of your roadway, and it actually runs right into either a stormwater facility or your local creek. So, and that either shows that we're going to have some filtration or less filtration in between the roadway having pollution on it and a healthy aquatic habitat that is on the side of the road. So these could include rain gardens, swales, or ponds, for example. Next slide. And you can, again, push through on this one. There's a couple more species. So this shows how spills and leaks should be reported to your local water quality agency. Next slide. And, oh, there was one back. Can you go two back? There we go. And this just, again, shows sort of that overall picture of how our stormwater is not yet officially filtered in the same way that our water is filtered in water quality facilities of our actual water treatment plants, and our sewage is filtered. Both of those have big permits that are covered. Our stormwater has a permit that covers it as well. But the more that we can put these little mini habitat spaces in, the more those can act as filtration devices to help our water from the rain be cleaned before it gets into our rivers and creeks. So with that, it kind of gives you a background, and you can fast forward to the end. That's me. If you need to reach me, I'm at Oak Lodge Water Services. I do our water quality monitoring, and this is what my watershed used to look like before humans developed it. So I like to end with this slide because it gives you the magnitude of ecosystem magic and health that used to exist. And I like to think of how many amphibians might be living in that space today if we can recreate that for the future. So with that, Katie, I'll pass it off to you.
Excellent. Thanks so much, Lara. All right, so now I'm going to be moving into talking about those amphibians that may be living in your garden and the ones that we have in this area. And this is going to be focused on, sort of the amphibians of the Clackamas area, the greater Portland metro area. But a lot of these same types of amphibians live in any different place, because it sounds like we have people tuning in from all over the world. So a lot of these same things will ring true everywhere. So overall, what I'm going to talk about today is just, first of all, what is an amphibian? Because it's not something that everyone's familiar with. Talk about their life cycle to figure out what their habitat needs are. Talk about the specific species that live around here and similar species live elsewhere, and what you can do to help them in your garden. If it sounds like a lot of you want to attract them to your garden, where maybe you don't have them right now, and a note on stormwater ponds that Lara was just talking about. And something that I wanted to start this with is that all of the photos that I'm showing here were taken either by myself, or there's a resident who lives in Gresham named Kaz Zuvakauskas, who has taken these photos either in Gresham or in Portland. So these aren't just some, random internet photos from somewhere in the world. These are actual individuals that live here in our urban area. And of note, I'll talk about when we get to the species later, but Kaz has a bunch of these living in her yard, and she doesn't have a very big yard. So it is possible if you do the right things. Let's see if I can move this Zoom menu up here so that I can see my slides better. Okay. So let's start with, what are amphibians? So there are a few basic types of amphibians. The first one you might think of are frogs. So lots of different types of frogs. That's sort of the common thing that we think of. And then we have salamanders, which is the other main type. And we have lots of different types of salamanders here that have lots of different life cycles. And of note, toads are a type of frog. They're a subset of frogs, although we'll often say frogs and toads. Technically, toads are a type of frog. And similarly, newts are a type of salamander. So toads are basically the frogs that can live in drier environments. They have rougher, bumpier skin, and they tend to produce more toxins. Similarly, newts have drier, bumpier skin and tend to produce more toxins as well. Okay, here's a question for the chat. There's a third type of amphibian. There's the frogs, the salamanders, and then there's a third type. Does anybody happen to know what that third type is? I'll give you a minute to try to write that in. And a clue, none of them live in Oregon, that's for sure. I've never seen one before. They're pretty rare to see. They tend to live in tropical areas, and they pretty much only live underground. And so these will be the only photos that aren't taken by Kaz or myself and aren't from this area. Okay, I see one chat. Oh, if I can get to it here. Ooh, okay. Okay. Slow worms. I'm not sure what that is. That might actually be those, though. Axolotls are a type of salamander. Skinks are a type of lizard, which aren't amphibians. I'll talk about that in the next. Mud skipper is a type of fish, not an amphibian. Newts are salamanders. Axolotls are salamanders. Skink again, which is a reptile. Okay, any last guesses? Good, I'm glad I can introduce you to something new then today. Aha, Sicilians, correct. Not from Sicily, but these are, and maybe they're also called slow worms, I didn't know. So these are Sicilians, which are amphibians. They don't look at all like frogs or salamanders, but these three types of things are more closely related to each other than they are to anything else. They have no legs. They usually have skin that grows over their eyes, so they can't see at all. They have sharp little teeth. They have these weird little like tentacles that stick out the front. They mostly live underground. They kind of look like a worm, but they have a backbone and everything else that a vertebrate has. They kind of look like a snake, but they're not reptiles, they're amphibians. And we'll talk about that in the next slide. Super weird, and we don't know much about them because they're so rare and they live underground. So if anyone is looking for like something to research and get really frustrated on because you're going to see so few of them, Sicilians are something that we don't know much about. So what characteristics do amphibians have? In general, the word amphibian comes from the Greek and it means two lives. So amphi means two, so like an amphitheater means a theater that you see from two different sides, and bio is life, so two lives, and those two lives are water and land. And so many amphibians, most amphibians, spend part of their life in the water and part of their life on land, although not all. Some, like an axolotl, spends all of its life in the water. Some, like let's say the Oregon Ensatina salamander that we have here, spends all of its life on land, but many of them spend part of their life in each. Uniquely for amphibians, they breathe and drink through their moist skin. So frogs and salamanders tend to be slimy, unless it's the toad or the newt that are drier, but most of them are slimy, and that's a mucus that helps them to breathe through their skin. So it's almost like they have their lung on the outside of their body. Whereas a reptile on the outside will have scales. Reptiles are pretty much always going to be dry and they have scales. Amphibians have no claws, they have no scales. You can kind of see the little feet of the salamander here. There's no claws and no scales at all, that wet, moist skin. And these three pictures here are all of the same salamander at different points in its life. This is the northwestern salamander. So on the left is the eggs that the salamander lays in the water. I'm lifting them out of the water here for you to see them. And then this is when it's hatched into an aquatic larva, and then it goes through metamorphosis and becomes a terrestrial adult. And their eggs are really unique too. Their eggs are moist and they have no shell. So all these little dots in here, these little yellowish gray dots, each one of those is an embryo that's going to develop into a salamander larva. So it's sort of like the yolk of a chicken egg. And you can actually watch them develop through this clear jelly before they hatch out. And like a bird egg has a hard shell, right? Like a chicken egg. And then if anyone's ever seen a reptile egg, like a crocodile egg or a turtle egg, they have a leathery shell. Whereas amphibians have this gelatinous mass on the outside. And it needs to stay moist all the time. So either they lay that in the water, or if they lay it on land, it tends to be somewhere moist, like under a log or under some leaves where there's still moisture. And I'm going to talk through the life cycle of what amphibians are doing at different times of year, because amphibians, many of them tend to move around a lot and they'll use different types of habitat at different times of the year. So your garden might be good for them at one or multiple times of the year. So in the fall, when the fall rains start around here, we tend to have sort of a hot, dry summer, and then the fall rains start. And as the ground is moistening, the amphibians start to get excited that their life-giving water is coming, and they start moving towards their breeding sites. And you'll tend to find them under rocks and logs. So this is an example of a place that I find tons of salamanders and some frogs. If you go turn over these logs, they're hiding under there in the fall. And then in the winter, they're breeding and laying their eggs either on land or in the water. So this is an example of 3 tiny little salamander eggs that are in this little blob of jelly. These are long-toed salamander eggs. And they're laying them right now. This is the peak time for amphibian egg laying. So if anyone has a pond, or if there's a local wetland or pond nearby, go take a peek in the water and see if you can see any blobs of jelly with eggs in them. Some of them are small, like only the size of a marble. Some of them get up to the size of a grapefruit. So this is the time to do that. And then in the spring, they'll hatch into larvae or tadpoles if they're in the water, or if they're terrestrial species, they'll hatch out into tiny little juveniles on land and usually stay near their mom if they're terrestrial. And then near sort of the end of the spring into summer, the ones that are in the water most of them go through metamorphosis in the summer sometime. And move onto land. And so that's when they're leaving the pond and they turn into little froglets or toadlets or little salamanders and crawl out and try to find somewhere moist. And then as the hot, dry summer sets in, they'll go either under rocks and logs, or they'll actually go underground itself until they get to some moisture. And they go through a type of hibernation that's called estivation, AES, where their body just slows down and shuts down until they get those rains in the fall again. And so maybe you have a pond on, you're lucky enough to have room and the ability to have a pond in your garden, at which case maybe you'll have some amphibians actually laying their eggs in there or hanging out near the water, or maybe you just have some logs or maybe some piles of leaves or sticks, and maybe you'll have some during their terrestrial phase. They might even be down below areas in your yard and you wouldn't see them because they're down in the soil below. Okay, so looking at the aquatic lifestyle, and I apologize, I have allergies right now, so I'm going to be blowing my nose just a little bit. If you're an aquatic amphibian, you're laying your eggs right now in the water, hatching out into these tiny little tadpoles, and then you start to grow legs and resorb your tail. And then sometime in the summer, that tail's completely resorbed. It doesn't fall off. They actually use all that energy in growing their legs. And then you become an adult frog. And then you'll probably go back. You might wait a year to get a little bit bigger, and then the next winter go back to your pond and lay some more eggs. And that's similar for salamanders. They'll lay their eggs in the water, hatch out into a larva, and then go on to land. And then in a couple years, come back and lay their eggs. Some species, like this northwestern salamander, actually has the ability to go through a process called neoteny, which means that they go through development to become an adult. They go through sexual maturation. They can lay eggs and produce offspring, but they don't go through metamorphosis. They stay in the water in their juvenile state. So they still have their gills. So if you're going through metamorphosis, the salamander larva will absorb these weird gills that stick out the side of its neck that help it get oxygen. And it'll lose its tail fin because it doesn't need to swim in the water as much to go out on land. But some of them just stay in the water and they keep those gills in the fin tail. So if you're familiar with axolotls, that's what those do. They never go through metamorphosis. They stay in that juvenile state with the gills, but go through sexual maturation to become adults. But for species like the northwestern salamander that we have here, it's sort of a choice that can happen any year. So, and it could be different between siblings. So let's say all these eggs hatch out into a pond, and let's say pond life is pretty good. There's tons of food, there's plenty of habitat, it's not too crowded, the pond hasn't dried up. They may stay in the pond for several years, keep their gills, and start to reproduce as neotenous adults. Or let's say there's not a ton of food or the pond's starting to dry up. Some of them will go through metamorphosis and become terrestrial adults instead. And it's a one-way street. Once you've gone through metamorphosis, you can't come back. And if the pond continues to dry or there's just no food there, they'll all go through metamorphosis and get out. And amphibians play a really important role in the ecosystem, and most of what they do actually is get eaten. They are a nutrient transport up the food chain. So many different animals eat amphibians. So this is a picture of a giant water beetle or a giant water bug eating a Pacific tree frog. And this is a robin eating a Pacific tree frog. And this one actually isn't my picture. A random guy I ran into in Oaks Bottom Wildlife Refuge showed it to me, and I asked him to email it because I thought it was so cool. And so basically, these frogs and salamanders will go and lay hundreds, sometimes thousands of eggs, right? Usually in a pond. And those tadpoles will go and they'll eat all the algae, they'll eat little phytoplankton, and the salamander larvae will be eating tiny, tiny little bugs. The larvae themselves are small, and they're eating all these tiny little bugs. And then everything else can eat those tadpoles, or when they go through metamorphosis, can eat those little frogs, because, maybe 1 in 10,000 actually survives to adulthood. All of those are taking these nutrients that are washing down into the pond and turning into algae or snails or whatever else, and transferring that back up the food chain, because a lot of these bigger animals can't eat those tiny little things. They can't eat the algae, they can't eat the tiny little water bugs, but they could eat a salamander, they could eat a frog. So one thing that I think about is that they have sort of a similar role to salmon in the ecosystem, where nutrients are always washing off the landscape to a low point. There's often water at that low point. And if that water washes into a stream, it eventually flows out to the river and out to the ocean. So there's always sort of this net flow of nutrients off of the land and into the ocean. And so salmon have this important role where they go out to the ocean, and that's where they grow and get big. They take all those nutrients that have gone out into the ocean and become little things, and they turn them into these big salmon bodies. And then they swim back upstream and bring those nutrients up into our streams and then die and get eaten by all the other animals up in our forests. And that's one reason that we have such large forests in the Pacific Northwest, is because of all of those nutrients that have come up. And so amphibians are doing a similar thing. All those nutrients are washing down into ponds. If it doesn't drain to a stream, there's often a pond there, and it has algae blooms and other things. And those amphibians are sitting there eating up all those nutrients and then hopping back up onto the land and getting eaten by things, so helping to move those up. So here's a picture of the 11 species of amphibians that we have in the Willamette Valley right now. We're talking a little bit before this started that there also used to be western toads, but those have been, as far as we know, extirpated from the Willamette Valley, although they're around sort of the outside edges. So here there's 11 species. That's maybe more than you thought. It's also just not that many. That's one thing that I love about amphibians is that for a while I tried to be a bird person or a plant person, and there were, hundreds of birds. I was having trouble learning them. There were thousands of plants and I couldn't learn them. And then there's only 11 amphibians. It's completely doable. You can totally learn these and get to know them all. And some categories for them. 10 of these 11 are native. So the American bullfrog is non-native. It was introduced from the southern United States, but the vast majority that we see are native. And even, within a pond, there are sometimes bullfrogs, I'll talk more about their habitat, but they're the vast minority. There are way more Pacific tree frogs and red-legged frogs than bullfrogs. We have 2 species that are Oregon Conservation Strategy species. So the red-legged frog and the Oregon slender salamander. Their populations are small enough that this is sort of the step before threatened or endangered. So they're sort of on the watch list. And then in terms of where they breed, all of the frogs and 4 of the salamanders are aquatic breeders, so they lay their eggs in water. But then we have 4 salamanders that lay their eggs on land and never go to water their whole life. So I'm going to go through each of these species just a little bit to tell you about them and show you what they look like. So the long-toed salamander is a small salamander. It's a few inches long, and it's very common and adaptable. This is what its eggs look like. This is what the larva looks like. Here's the adult. It usually has a yellow stripe on its back. And sometimes we'll even find eggs of this species like where someone drove through somewhere and left a tire rut and that filled with water, and they'll come lay their eggs on little pieces of grass. So they can be super adaptable. And you might find them around your yard, hanging out under a bucket or under a board or something like that. They actually love being under big sheets of black plastic. That's one of the places that I've seen them the most, where some plastic was put out like for a restoration project to try to shade something out. And then we went to rip it up to go plant again. And there were just tons of long-toed salamanders hanging out under there. So, that works too. Northwestern salamanders are a large, robust salamander. They get to be almost 10 inches long. They're sort of rare in urban areas. You'll find these a lot more sort of out in the forests outside of the city. This is one of the species that can stay in the water year round with neoteny. And they have this really cool symbiotic algae that lives in their eggs. So their egg jelly is so thick that you can I could pick it up out of the water and throw it to you across the room and you could catch it and it wouldn't change shape. All the other species have this sort of loose jelly. And because it's so thick, that means that it can survive freezing, it can be out of the water for several weeks, and the embryos will be fine. But it also means that oxygen can't make it through to the embryos, and then the waste that the embryos produce as they're metabolizing can't make it out. And so they've developed this symbiosis with an algae that lives along with the embryos, and it eats that waste that they're producing and breathes the carbon dioxide that they're producing and produces oxygen for them. So each one of these little embryo cells has sort of its own little self-sustaining ecosystem as the embryo is growing. And something that was discovered recently is that the mother salamander actually carries those algal cells in her ovaries and passes them down when she lays her eggs. And it's the only known plant cell that lives inside of an animal and is transferred down from mother to children. So that's pretty cool that salamander lives right here where we are. And we have the rough-skinned newt. It has that rougher, bumpier skin, although when it's going into the breeding season, its skin actually gets really smooth. It has a bright orange belly because it's super toxic. So if you ever find a rough-skinned newt, totally fine to pick it up, check it out. Do not eat it. And if you see any white goo coming out of it, that's the toxin. Wash your hands extremely well before you eat anything. It's one of the most toxic substances in the entire world. People have died when they've accidentally ingested a newt or when it has crawled into their cooking pot while they were camping and they didn't know it. So really cool, fairly common, more so outside of urban areas. Then we have the Oregon Ensatina salamander. So this is a fully terrestrial salamander, stays on land its whole life. It loves to live under logs and rocks and leaves and ivy, things like periwinkle or kinnikinick. often non-native species. So all of our terrestrial salamanders actually do pretty well under English ivy and vinca, periwinkle, which can be, I don't know, just something to be aware of. Sometimes when someone is removing a bunch of those non-native species, they often remove salamander habitat as well. This species is many salamanders can do this and many lizards can too, but this species in particular will lose its tail really readily if a predator is attacking it. You can kind of see there's this constriction at the tail here. And so that'll fall off if a predator is attacking it. It's basically just fat storage, so it would prefer not to lose it because that helps it get through the lean times, but it can lose its tail, it'll wiggle around, and then the salamander gets away while the predator is distracted and it'll regrow its tail. And Encetina salamanders are something that's called a ring species, which is pretty cool. So what a ring species means is that it has this range where there's a lot of variation throughout the range, and on the very edges of that, where it comes back together, there's so much variation that the populations can't interbreed anymore. So here's the range map of Encetina salamanders, and you can see sort of that they look different in different areas. These are all subspecies, and these are the subspecies names. And originally, the Encetina salamanders were just in Oregon and Washington, and over many millennia, they migrated down into California and even into Mexico. And as they're going into California, they can't live in the Central Valley. It's too hot and dry there. So they lived in the coastal range and in the Sierra Nevadas. And as they went through these areas, each population became a little bit different than the one next to it, but they could always still interbreed with the ones next to it on both sides. But then, over enough millennia, they came and met again where those mountain ranges come together in the south, and those were so different from each other that they can't interbreed. So this begs the question then of, is this one species? Is this multiple species? What is a species? So kind of a unique way to observe changes in one species and how that looks over time. Then we have the redback and the dun salamander. So these both look really similar. I actually only put one picture in here because they can be really hard to tell apart. They also stay on land their whole time. And this salamander can be extremely abundant, where sometimes it's more than half of the vertebrate biomass in a forest. So for example, if you go to a forest and you put all of these are called plethodontid salamanders. If you put all the plethodontid salamanders in the forest on one side of a scale, and then let's say like all the deer on the other side of the scale, it'll often be heavier for the salamanders because they can be so abundant. But you'll hardly ever see them. They mostly live under the leaf litter, right? So these salamanders in particular love to have a big thick layer of leaf litter, like a foot thick. And so you'd really have to dig through all of that to find the salamanders. And that's one reason that you might not find a ton of them in your garden if, it's pretty much, if you don't have thick layers of leaf litter, if you haven't left your leaves there for years and years and years to decompose, you likely have, more of a hard ground. And they like to be in that area where it's hard to tell, is it leaves? Is it soil? It's somewhere in between, that duff area. So if you have the ability to, leave the leaves where you can, maybe put them in a corner, that's where these sorts of species love to hang out. And then we have the Oregon slender salamander. The species is pretty rare. It was thought to only be in a few places in and near the Cascades in the entire world. And then it was discovered in Gresham in Kaz's yard, actually. Well, first in a park and then in Kaz's yard. Here they are in a cinder block wall in her garden, where they're now known in Gresham, a couple places in Portland, and who knows where else. So they'd been there for hundreds of years, and we didn't know until a few years ago when someone did some surveys. They're really pretty. They curl up when threatened. They have these tiny little legs. They kind of look like worms with eyes. And as far as we know, they live in old growth forests and in cinder block walls, right? And so thinking about what makes good habitat, it would be great if you had a 300-year-old cedar tree with all the bark coming off and it's creating duff. That's where these salamanders love to live. Turns out they also love to live in cinder block walls and must provide the right type of moisture and the right amount of bugs that they eat and protection from predators. And here's the Pacific giant salamander. This is a huge salamander. It gets to be a foot long. Here's my finger down here with one I found in Forest Park. And this one lives in streams. It breeds in streams. It's the only one we have that breeds in streams rather than either on land or in ponds. And they can eat fish and ducklings. They can even take off the tip of your finger if you're not careful. They're pretty cool. I don't see them a whole lot. They're in streams, I know, throughout Gresham. I've seen the juveniles. I know they're in Portland in Forest Park. So check for these around. They could be in streams, and then the adults can, this is a neotenic adult where it stayed in the water with its gills, and this is one that's gone through metamorphosis.
Katie, I'm just coming off mute to give you that 10-minute check-in.
Okay, perfect. Thank you.
Mhm.
And here's a video of a Pacific giant salamander in a stream, and you can kind of see its little gills breathing here. And there's a sculpin next to it. Okay, and then we have our frogs. So there's only 3 frogs here. So if you see or hear a frog, you probably can figure out which species it is. We have the bullfrogs, which are large, the red-legged frogs, which are medium, and the tree frogs, which are small. Someone might be saying, what about the chorus frogs? So tree frogs and chorus frogs are the same thing. In the time I've been studying them, the name has gone back and forth 4 or 5 times, and their scientific genus has changed to like 5 different things. So tree frog, chorus frog, all the same thing. So first, the bullfrog was introduced from the southeastern United States. They tend to like permanent hot water without many plants in it. So if you have sort of a big open warm area, that's where they'll be. So if you don't want bullfrogs, avoid that sort of situation. Most of our native species prefer a pond that dries up at the end of the summer, and bullfrogs can't live in those ponds. If you want to identify it, it has this fold around its eardrum, and they're big, and they lay their eggs in the late summer. Sometimes people tell me in March, hey, I found some bullfrog eggs, so I threw them out on the bank to do my part. And I was like, those weren't bullfrog eggs, those were red-legged frog eggs. Please don't do that. So these lay their eggs in the late summer. You might hear them calling them. They sound like a big bull. This is the red-legged frog. They used to be extremely common, but they've lost more than 90% of their habitat and population. Because their ponds have been filled in or drained for agriculture or urban areas. But urban ponds are found to be some of the best habitat. So that's what my dissertation research was on, was finding them in these constructed ponds in cities. And so you can build a pond and have them come if it can be big enough. They need a little bit bigger pond than the tree frogs do. A tree frog can maybe be in a pond that's only a few feet wide. A red-legged frog needs a pond that's probably at least 10 feet wide and 2 feet deep, because they have these really big egg masses. And then there's my very favorite species, the tree frog or chorus frog, extremely common and adaptable, very recognizable call. You hear it all the time. They have this black stripe that goes through their eye. They don't get very big. They have these sticky toe pads. They can change color. And a reason that they're my favorite is because they're so adaptable. You might find these just in like a 5-gallon bucket you leave in your backyard. I found them in the middle of the desert, in the dunes, up on top of mountains. They can be everywhere. So as the environment continues to change and humans alter it, they'll still be tree frogs, even if some of these other species don't do well. I think here's a video of what the tree frogs sound like. So in general, if you hear a frog in Oregon, it's going to be a Pacific tree frog. They're by far the most common. They call all the way from the fall into the summer. And here's a video of what it looks like when the frog calls. This is his expanded throat pouch, and he's going to squeeze the sides of his body to expand that. This is Buddy calling. And
Well, Katie,
here's
the
some that,
audio isn't coming through on our end. I don't know if you could hear it on yours.
oh, really? You couldn't hear anything? Okay, well, oh well. Here's some in a little puddle, where there's tons of tadpoles in here, so they can be super adaptable. So this would be probably the easiest species to get in your yard, but beware, they're so loud. Sometimes people get them in their yard and then they're like, this is way too loud for me, I can't sleep. So you have been warned. So in general, what can you do in your garden to help these? So a lot of the things I've already talked about, but just to put it into a few specific things. The first biggest thing is just to leave debris in your yard. Leaves, logs, branches, anything that provides hiding places any time of the year, especially an escape from summer heat. So plants, leaves, logs, even a board. They love like boards of plywood. Tons of salamanders and frogs hang out under those. Like I said, black plastic, cinder block walls even. But one thing that Kaz always says is be a messy gardener. If everything looks all nice and manicured, you're probably not going to get amphibians. They need sort of that rough, messy area. As with pretty much all animal life, limit pesticides, herbicides, and fertilizers. If you do use them, be sure to follow the label, but better even to eliminate them. That protects the amphibians themselves and all of their food. Their main food source is little bugs. So if there's no little bugs there for them to eat, they're not going to be there. Providing ground cover. So much of what amphibians want is their predators are often, you could imagine, about a foot off the ground. So think of like a raccoon or a coyote or something walking by, or a bird. And so if they can be hidden on the ground from that view, then they're happy. So any plant that allows them to be under it and not seen from a foot. So that could be ground cover like ivy or other, they love ferns, hiding under ferns. So any of that, protection from predators and from the sun, because they can get too hot and dried out. Ponds are sort of the golden thing that you could build to help have amphibians in your yard. Even a breeding pond would be the ultimate best, but it can be difficult. They may not even be able to get to your pond. You could have the perfect pond in the world, but if you're separated from the nearest amphibian population, it can't get there. But this is a pond that Kaz built in her yard. She just put this black plastic liner and it fills with rainwater here. And she gets 4 species of amphibians breeding in that tiny little pond there. Really important, they cannot live in any sort of chlorine, including the chlorine that's in the tap water. So make sure not to just go and fill this up with a hose, that's unless you're on well water. So either rainwater, or if you can somehow dechlorinate water if you're trying to use tap water. And they prefer plants in the pond. So this was built, or this picture was taken right before she put the plants in there. So this is one with some plants growing. In general, you want your pond to have water January through June. They'll start to come to the pond and breed around January, and then they tend to be done with metamorphosis by the end of June. Ideally, it would dry up after there, so then you don't get bullfrogs and some of their other predators. Ideally, your pond is 1 to 3 feet deep. That's sort of the depth that they like the pond for their eggs and their tadpoles. They love rooted, thin-stemmed aquatic plants. So things like sluice sedge and juncus are some of their favorites. And really importantly, they can't coexist with fish. Fish will eat the eggs, they'll eat the tadpoles. So if you have a koi pond or something, it's just not going to be a frog pond. You got to kind of choose one or the other. And here's a video that Kaz took in her little pond the other night, where here's a northwestern salamander, female, and then these are a bunch of male long-toed salamanders who are hoping she's actually a large female long-toed salamander and that she'll breed with them, but she is not interested, and she's just going around trying to find a male northwestern salamander. So they're mostly active at night. It's possible that if you've only ever been looking for their amphibians during the day, you may have them and you've never noticed them. You pretty much have to go out after dark with a flashlight to try to find most amphibians. And so just to note, this was some of my dissertation research looking at constructed ponds here for the species that we find in this area, and just looking at what proportion of ponds they were in that were natural versus constructed. And you can see for all of these, there were at least as many in the constructed as the natural. So they don't actually care if it's a natural pond or something that people built. They just care if it's the right depth and has the right plants in it and has water the right time of year. So the quick note on stormwater ponds, these are ponds that are built generally in new neighborhoods to help reduce flooding and clean runoff, and they can often be excellent amphibian habitat. So just in this little pond here that was built for this neighborhood as its detention pond, we're finding red-legged frogs, tree frogs, northwestern salamanders, and long-toed salamanders, and it's just full of them. So in general, I'm pretty encouraged by amphibians compared to some of the other things I'm working on that maybe are getting worse every year. Amphibians are doing pretty well. They can live in cities. They are often doing quite well if you give them half a chance. You know, a lot of their wetlands were filled in. We tried to rebuild a few of them and they come right back. And all the species that I'm studying here are generally increasing every year. All right, that's it. So let's have time for questions.
Awesome. Thank you so much, Katie. We've had a couple questions roll through and some came through on things that you then subsequently addressed. So I'll do my best to kind of tweak those or add a bit of specificity. One of the earlier questions was, do amphibians lay eggs in creeks with flowing water?
So most don't. The Pacific giant salamander does, and newts can too as well. Newts are kind of adaptable. They can lay in either still water or flowing water. Doesn't tend to be rushing water, but the Pacific giant salamander will lay in rushing water.
Could you discuss climate change with changes to usual species estimation?
Yeah, so in general, all of our amphibians, their hard time of year is the hot, dry summer. So if summers are getting hotter and drier, that's going to be harder for them. They have to go longer without food, longer above ground, or longer below ground without coming up. So yes, definitely. If we get more rain or bigger rainstorms, they're pretty excited about that. But the hot, dry summers are hard for them. I'll also note that here, bullfrogs don't seem to be a huge problem for amphibians here, like they are in California, but that may be partially because it's sort of the edge of bullfrogs' ability to live. It's a little too cool for bullfrogs. So if it gets warmer, bullfrogs may have an edge on some of our native species. That's also true for things like the chytrid fungus that affects amphibians. It tends to not take hold as much here, but perhaps if it got warmer, that may be more of a problem here.
Okay. Yeah, someone had asked about bullfrogs and maybe kind of what to do about them before you
Oh.
got to your slides about bullfrogs. Would you recommend any actions if people are able to confirm that they have bullfrogs?
Yeah, great question. So, part of my job for a long time was to try to like eradicate bullfrogs in a certain area, and it is often fruitless. There have been some very concerted eradication efforts that have gotten rid of some. However, if you have good bullfrog habitat, just like killing individual bullfrogs probably isn't going to get rid of them, right? Because they're already everywhere. One female can move 10 miles and she can lay 10,000 eggs a year, right? So it's difficult to get rid of them. What's better is to try to not have bullfrog habitat. So if it's a big warm pond that's around year round, that's probably bullfrog habitat. If it can either dry up or have more shade or more plants, then it's less likely to have bullfrogs. And actually here we found that bullfrogs can coexist with the native species pretty well if there's enough refuge for them. So lots of plants in the water so that the native species can kind of hide.
Okay, interesting. Thank you. Yeah, you had mentioned that there tend to be more Pacific chorus or Pacific tree frogs than bullfrogs, and I was wondering if that was like by numbers alone or maybe from a biomass perspective, like as far as food
Yeah.
availability goes.
Yeah, so in general, when I've done studies sort of throughout the Portland metro area, and by numbers alone, I would say there's probably 10 times 10 to 100 times more red-legged frogs than bullfrogs that I find, and thousands times more tree frogs slash chorus frogs that I find than bullfrogs. So there are definitely bullfrogs here, but they tend to be in places like there's Whitaker Ponds and Smith and Bybee wetlands up in northern Portland, sort of big, shallow, warm places, and they'll tend to be a lot there. But the vast majority of places that our native amphibians are breeding, these tiny little ponds that dry up, the bullfrogs don't like them, or they might come hang out at them for a little bit, but there'll be like one bullfrog there and tens of thousands of the native species.
Got it. That's encouraging in the context
Yeah.
of invasive species work.
Yeah, exactly. I would often, when I started doing all this work, people would often just assume that whatever frog they saw was a bullfrog because they're like, oh, I'm in a city and cities are crappy habitat. It's like, no, it's pretty rare actually. If it's a bullfrog, it's much more likely to be one of our native species.
Neat. What resources do you recommend if someone is interested in constructing a pond in an urban area? And it seems like your dissertation might be related to that, but
Sure, yeah, you could check out there's one if you go to Google Scholar and look up my name in amphibians, there's one about amphibians in urban areas, and that talks about sort of like the features of ponds that are the best, but they're mostly what I highlighted here. I'm pretty sure Xerces Society has a good like backyard pond like flyer. I wonder if Metro does as well. Apologize, I don't actually know.
that's okay. A related question that came afterwards was, do you need to have a water source nearby to attract frogs? And if so, how close counts as nearby?
Yeah. So in general, frogs will hang out close-ish to water. So probably yes. If there's no water within, I don't know, I'll randomly pick like somewhere between 1/10 of a mile and 1/4 of a mile, you're probably not going to get many frogs in your yard. They might be passing through somewhere. But if there's one within, yeah, I don't know, several hundred feet, then you could very likely get them.
Oh, thank you. We're getting to the end of the questions that I have received. I just want to point out someone followed in chat with a bullfrog live trap and then also a resource for pond building based out of Wilsonville.
Perfect. Thank you.
So yeah, that's pretty cool. Are there any, you mentioned that Western toads have been extirpated in the Willamette Valley. Do you know if there are any efforts to reintroduce them?
Oh, I don't know that. That's a great question. And I think my understanding is it's mostly just that their habitat was disturbed, so there's sort of nowhere to reintroduce them to. But
Meaning,
yeah, that
meaning
would be interesting.
development kind of eliminated their habitat?
Yeah, exactly. Most of their good breeding ponds were either drained or filled in, largely with agriculture before even urban development.
Right.
The
Okay.
closest I've seen them, I've seen toads at Dabney State Park on the Sandy River. So that's getting close to the urban area here. So it's spot. And actually, I saw on iNaturalist once, someone had a picture of a Western toad from Tanner Springs Park, I think, in downtown Portland. And I was
Wow.
like, what's that? So I assume someone came and put that toad there, must have gotten it from somewhere else and put it there. But
Yeah, had a
people are,
accidental tag
yeah,
along.
exactly. Who knows? Maybe it'll take hold.
Yeah, that would be really cool. Okay, well, I'm not seeing any other questions come through chat, so I'll ask one more out of my own curiosity. You said on the Pacific tree frog slide that they change colors,
Oh,
and I know that I've seen bright green ones and I've seen brown ones. When you say change colors, can you tell us more?
yeah. It's funny, I actually learned this because I had a project where I was trying to see what type of roads were barriers to frogs, and so I was catching them and tattooing them, and then was trying to recapture and see where they had gone. And so I had a permit to keep some in my apartment so that I could see how well the tattoos lasted over time. And so when I caught them, I made sure to catch a bright green one, a dark green one, a light brown one, a dark brown one, so that I could tell them apart. And then when I got home and I looked, I had 4 bright green ones. And then I like put them in the cage and I had 4 dark green ones. And then I like put the mister in and I had 4 light brown ones. So what I understand of it is that they can change it's not like instant, it's not like an octopus that quick, but or maybe not as fast as a chameleon, but over the course of like 2 minutes, maybe they could go from bright green to dark brown. And not exactly sure, but people think it's often in response to thermoregulation, so trying to retain or dispel heat or moisture. And then if you've seen them, they often have a pattern on them, like dark brown spots or striping, and that pattern will always be the same. So when they are dark brown, it'll always be that same dark brown pattern. And it might go away and they'll be entirely bright green, but when they turn dark brown again, it'll be the same.
Neat. That blew my mind. I was not
Yeah,
expecting it to be such a dynamic change.
yeah, I had no idea.
I have a
That's really
quick question as well. Whilst I'm here, I know we've got so we have bullfrogs here at the ELC, and you're saying catching them is not really going to be effective. Do the bullfrogs actually eat the larvae or the tadpoles of the other species, the native species that we have here? Because we do
Yeah.
have different ones, but
Yeah, they definitely can. And I did a gut content analysis of bullfrogs at Whitaker Ponds when I was trying to eradicate them at Whitaker Ponds. And so I would when I euthanized them, I would then cut open their stomach and see what they had been eating. And I never found native amphibians or turtles in their stomach, although they've been documented to do that in many places. So I'm sure they do sometimes. I found a lot more invertebrates and little fish in there. And I actually found a bunch of juvenile bullfrogs. They were cannibalizing a lot.
Oh.
So that was interesting. So I'm sure they do. I'm not sure that it's a main food source, but it is true that some, especially if there are ponds that don't have a lot of refuge, I tend to not see as many native species when there are a lot of bullfrogs. And is that because it's not a great pond for native species because they like the smaller, cooler, more vegetated ponds, or are the bullfrogs eating them? It's possible.
Thank you. Very interesting, fascinating.
So was the best management practice for bullfrogs to remove the egg masses during the summer?
You can. They're just going to lay another one when you don't see it, I feel like.
Yeah. I'm
And
thinking in
keep laying.
particular at the ELC, like they have
Yeah.
active, volunteer events and community science work and things like that. So there might be a bit more capacity in that space
Right.
to do that.
Yeah, the places that I know of that have actually like made a dent on bullfrog numbers have extensive egg mass removal, although their eggs are only around for 4 days. They lay these huge egg foams on the surface with poppy seed size eggs, and they hatch within 4 days and they're gone. So it's really easy to miss them. And then also trapping and euthanizing adults, which can be difficult because they become trap shy. The people I know who have eradicated them actually go out at night with a .22 rifle and shoot the adults with a headlamp, and that has at least temporarily eradicated before any others come in. But it's sort of it's an ongoing battle.
Yeah. All right.
There's
Thank
also
you.
coexistence, which is what I tend to preach instead. There may just be a bullfroggy pond, and that's just going to be a bullfroggy pond, and maybe there's native amphibian habitat nearby.
Mm-hmm. A question came through. Do amphibians eat seeds?
Not that I know of.
Are they mostly carnivorous?
So in the adult stage, they are entirely predators, mostly eating, they'll eat slugs, bugs, little things. With frogs, they'll often say whatever they can catch and fit in their mouth, they'll try to eat. But they don't tend to eat any vegetation as adults. As larvae, the salamanders are predators, but the frogs only eat algae, basically. Frog tadpoles just scrape algae as tadpoles.
All right. Thank you. Well, I haven't seen any more questions come through. I am going to pop the evaluation link in the chat one more time for everybody. That is helpful for us again. Here it goes. Yeah, that'll help develop some structure for next year's
Series.
agenda or series lineup, the lineup for next year. Otherwise, yeah, I think Michelle,
Yeah, thank you so much, Katie and Lara, for really fascinating information presented to us today, and to all of you for joining us for this series, because we've really had a great participation, and we hope that you've learned some new things. If there are more things, as Alexis said, that you would like to learn about, as I'm planning the series for next year, I'm going through trying to figure out what will be things that you would like to learn about. So any suggestions of what you would like to learn is always helpful in our evaluations. Thank you so much. This has been absolutely fascinating, wonderful talk. And we hope that you will, if you missed any part of our presentations, we will have them up on our website. The recordings are up on the website, and the recording link and any of the resources that were shared today will come to you in the next couple of days. So if you want to look up some of those extra resources. Thanks so much, everybody, and enjoy the sunshine if you have it. We have some here at the ELC, and we will see you all hopefully back in January next year. And if you have any questions, you know where we are. Okay, thanks, everyone. Take care.